Hi everyone, this video refers to lesson 14 of the Sound and Light scheme. This one is about correcting vision, and really this builds directly on what was looked at in the previous lesson on short and long sightedness. And actually when you're explaining this to students, I think you don't even need to draw new diagrams. You can probably just do what I'm going to do in this video and use the previous diagrams as a reference. So this was distant objects and nearby objects, because actually it's really helpful that they see this progression from kind of what it should look like, where you get the vision defect, short-sightedness or long-sightedness, and then how we correct it. So as we looked at last time, and I think, sorry, one thing I should say is this lesson does rely on introducing a new type of lens that we haven't looked at yet. I don't think that's the end of the world. But if you feel uncomfortable with that, you may wish to teach them about diverging lenses, which we haven't looked at yet beforehand. What I might suggest is a good place to do that would be in the lesson on converging lenses, and just show them that as an example of a contrast between the convex and the concave lenses. If you want to just wave your hands a little bit in this lesson, I think that's fine too, because hopefully they will get the idea, and the main thing is it's not about them really being able to necessarily have this perfect understanding at this stage. It's just, as I keep saying, an opportunity to reinforce these ideas about refraction and drawing the ray diagrams and so on. But I think because it involves another converging lens, the easier example to start with in this case is actually long-sightedness. So what you can do is start this lesson 14, by recapping on what you did in lesson 13. So the fact that what should happen is that for nearby objects your lens becomes fat. It refracts the light an awful lot so that it's focused on the retina. But sometimes, for some people, especially older people, their lenses are a little bit too weak. They can't get fat enough, they can't become powerful enough to refract the light that much. And so you end up with a focal point that's a kind of imaginary focal point that's behind the retina. How do you correct that? Well, this is why this one's a bit easier. You just need to add another lens to help it along a bit. So what you can do here underneath your diagrams that you've done, in fact I'm just going to move this down here like this. So to get this to the correct version where the focal point is on the retina again, if we sketch our diagram like this, and I'm going to draw my eye here like that. If we sketch this one, and remember this is the defective vision version, so we've got a relatively thin lens here, just like we had here. We've not got the ideal fat lens that is super powerful and refracts the light a lot. So we've got a relatively thin lens, but what you want to show is, well, we know that if it was just down to this lens, the focal point would be back here. So what we've got to do is add another, and I'll do it as a relatively thin one, we've got to add another convex lens in order to just do a bit of extra refraction before the light gets there. So what I can do is show this. If I do it like this, and you can illustrate to students that you get a bit of refraction there, so the light essentially is coming in as if it's parallel, like that. So this is the light coming in now, like this. And because this convex lens that you've put in front of the eye has already done a bit of the refraction, well now your eye's lens can do the rest. And I'm just gonna, these are a bit fiddly to draw, as you can probably tell. I'm gonna then sketch it like this and draw the focal point on the retina as it's supposed to be. And really the main thing here is that students are seeing the contrast between this one and this one. Without this extra convex lens, there's not enough refraction, so your focal point is back here. With the extra convex lens, there is enough refraction, so the focal point is on the retina as it should be. And these would be, this lens would be found in glasses. These would be glasses to correct long-sightedness. So again, But if you've drawn it like this, you don't need to write full notes or anything, because that's going to be relatively straightforward to students. But the main thing to emphasize to students is that if someone is long-sighted, you correct their vision with a convex or converging lens. And remember, those two are the same thing. Convex just describes the shape, converging describes the function, what the lens does. Now this second one, looking at short-sightedness, is a bit trickier. And again, a good way of starting here might be to actually just, if you wear glasses and you're short-sighted, that would be my position. I would probably bring my glasses in school that day and actually just get them under the visualizer and show students what the lens looked like. Or lots of your students are probably short-sighted, because younger people do tend to be short-sighted. So just ask a student if they're willing to share their glasses, and you can kind of get them under visualizer and have a look. What they should notice though is that they don't have a convex lens. They tend to be thinner in the middle, fatter on the outer sections. So again, you can then explain that and explain why it works. And again, I think it's fine, even though they've not studied diverging lenses in detail. I think it's absolutely fine, because you can essentially say, where converging lenses bring light rays together, well, diverging lenses or concave lenses do the opposite. They spread light rays apart. So in this case, what happens is we've got our incoming light rays from a distant object. I'm going to draw those like this. We've got our eye like this here, and we've got our lens, which, as we've seen in these previous diagrams, I'll just return up to here. We've got our lens, in fact I can leave that up. We've got our lens which is a bit too fat. So the reason a person is short-sighted is because their lens cannot get thin enough. It's always a bit too powerful. It refracts light too much, so the focal length or the focal point can never get all the way back to the retina. It's always, the focal length is always just a bit too short, hence you get the blurry image. But what we can do is say, well, okay, we've got this lens which is a bit too fat, like this. So what do we need to do? Well, we need to put some sort of lens in here. In this case, what we call a concave or a diverging lens, which is actually going to spread the light rays apart, in essence, to give this fat, overly powerful lens more to do. It needs to do more refraction, and therefore that's going to push the focal length back. So you can then show this as follows. This is not going to be the greatest diagram, but hopefully it's clear enough. Show that actually you're spreading those light rays apart. You're making them go a little bit wider, and therefore these have lots and lots of refraction to do in order to get the focal point to be on the retina. So because they have to do more refraction, well, that is actually quite handy. If I don't seem to have got my diagram very good here. Again, this is why it's worth you taking your time to practice this, because they can be very fiddly, these diagrams. Lined paper might be better as well than plain paper. But hopefully that's clear enough, at least for the purposes of this video, to show that what a divergent lens is exactly the opposite. Rather than, let me just move that down, rather than helping the convex lens in your eye out and doing a bit of the refraction for it, or doing a bit of the converging for it, this one's actually making it harder for your lens, so that it's got more work to do, and therefore that sends the focal length back from where it was before. So the main thing to emphasize here, and again this is just building on all the knowledge that they've been developing in the previous couple of lessons, but the main thing to focus on here is, if you've got a short-sighted person, what you're going to need to correct their vision is a concave or a diverging lens. And again, when they get to GCSE, they'll learn more about diverging lenses. They'll have to do ray diagrams for diverging lenses and so on. At this stage, I think it's fine to just say, well, it's kind of the opposite, and it does the opposite to what a concave lens does. It makes the light rays spread out rather than all coming together at one point. But hopefully that will give students a sense of why it is that this happens. So that is the last of this kind of mini sequence of lessons on refraction, where we covered lenses and the eye and vision defects and correcting vision. In the next video, we're going to move to the final part of the sound and light scheme, which is looking at white light and moving on to the electromagnetic spectrum.